Okay, so good evening, guys. Welcome back. So today is the first day. So, guys, we are starting our new batch, that is batch 2 on DevOps and AWS. So, this is our second batch. Batch 2 is on DevOps and AWS Cloud. So, guys, in our last session, we had an introductory session, right? Introductory session. So, basically, we introduce ourselves, all of us, and we try to understand each other about what we are doing and what we are aspiring to get into in the near future, right? And also like what is a roadmap, what we have to undergo with this course, DevOps and Cloud, and as well as like we also understood, like we got to know about the class timing, so many other things like we discussed on the first day itself, right? But our technically our course starts from today. So because today we are going to discuss all kind of a technical aspect. So today, guys, what we are going to cover is that today we'll try to understand what is DevOps is all about, right? And also there are many tools which are there in the DevOps, right? There are hundreds of tools are there, but we will not be discussing everything. We'll be discussing only few of them so that we are aware of certain most used tool in our day-to-day activity in DevOps. Okay. And cloud, I will not touch it today itself because cloud again it's a separate topic. So we have to go in detail with the AWS cloud, everything. So after that, like we'll understand, try to understand about the deployment strategies. We'll try to understand about any kind of testing aspects existing in the DevOps life cycle, and also finally we will see about like how to set up our lab. So basically, when we have to set up a lab means basically we are depend upon some cloud account. So either you can go with the AWS cloud or else Azure cloud or GCP cloud or any other cloud. Okay, you can even go with the DigitalOcean cloud, right? You can go with the Alibaba cloud. There are many cloud providers are there where you can go and create an account, right? And also we will see how to set up our cloud account and how to create the infrastructure or create the service which is required for our practicing. So many things are there, guys. Today we are going to cover it actually. Okay, so let's start our journey, guys, today. So I again welcome everyone and thank you for joining this batch actually. So guys, so the first question comes to our mind is that what is DevOps is all about. We have been hearing this. I know many of our people in our room, they know about this, what is DevOps all about, as well as many people are already working DevOps, right? So many people are aware of it. So what exactly DevOps? So like if you ask me, Rajesh, if DevOps is something like a tool, I don't say it as a tool actually. Okay, DevOps never talk about a single tool. Suppose you take one tool. Say for example, you take a Kubernetes. So do you say that okay, Kubernetes is a tool actually? Yeah, it's an orchestration tool. But is it altogether it's a DevOps? No, it's not a DevOps. So DevOps doesn't talk about any kind of a single tool, right? It is not about a tool actually. It is about a culture or it is about a way. So DevOps is a culture, or you can some people call it as a process, some people it as a way to achieve the I can say the development of the app, I can say, or just say application. Plus you need to even once you develop the application, you need to go and install that application, or we call it as a deploy the application into the environment or server, we say. Okay, and finally what happened, right? You need to even after installing of your application, after your application is running, so make sure to make the application running, and plus finally you need monitor the application, monitor or manage the application, right? So DevOps is the combination, or it is not, but it's a collective collection of development of your application, deploying the application into some environments or into some servers or into some cluster, we say, and make sure the application is up and running always, and finally you have to monitor the application so that the application is always available, so that the application is available, or the application has high availability. So all this process, guys, developing the application, deploying, make sure the application up, and finally monitoring, all this is nothing. It's like a way, it's like a culture. So that is all is about DevOps. So DevOps is like a process, or it's like a culture. It's a way to achieve it actually. So we know that whenever we want to design an application, right? So basically what happened, right, we'll try to understand the requirement of that application. Say, for example, the Swiggy is a company. You know about the Swiggy company, right? Swiggy is a company where they try to deliver, they try to do an online food delivery, right? It's an online food delivery application, right? So the person who had this idea about that, okay, why don't we use an application so that using that application, any person, like the end user or any kind of a customer or client, he can able to order the food through online with the help of our application. So that's how what happened. That thought came, that idea came. So that's the reason what happened. That once the idea came, they started developing the application. It means that firstly, for anything, right, you need to understand about the use case of the requirement. That's what the use case. Okay, the use case that we need to have an application which through which through an online you can actually able to order the food. That's what the use case of the requirement. And afterwards what happened, right, you need to come up with something known as a development strategies. Actually, it means that you need to understand, okay, what kind of a we have to use for developing the application. So language to be used, right? And what is the target audience to which the application is being developed actually, right? Because this is an online application app, right? So it is used by almost all customer, right? Across India, anywhere, anyone can able to order that application, right? And finally, what happened that once you develop that applications and everything, finally what happened that you need to go on, you need to deploy that application, or you have to install that application, deploy the application, deploy, or we can say install, both are one of the same actually. Deploy the application, and finally making that application to run so that that application is available to the end user. So this is all about it. So some thought came into the mind, and then what happened? Slowly, what happened? It turned into development activity, and finally we go and deploy that application. Once the development is done, once all kind of a testing is completed, everything. Finally, we say the product or that application or that website is looks good, it is working fine. Then we go and install it, and we will make it available to the end user. This is all. This is completely, we call, in the short, we call it as a completely software development life cycle. We call it as an SDLC, software development life cycle. So I will also discuss about more into what is the software development life cycle is all about. Okay, in some time we are going to discuss that, guys. Don't worry. But I'm just saying you from the very high level that, so we follow a process of doing all this activity, which we call the software development life cycle. It means that we will be involved in continuous development, deployment, we are continuous monitoring, everything we do through a software development life cycle, right? So that's all. So now what has happened means, when this thing started, it means that you need to come up with an application. So what happened, right? You will be involved in doing a development activity. You will be involved in doing a deployment activity. You will be involved in making your application up, and you will be involved in monitoring. All these things, whatever you see in the SDLC, it's all been taken care by the DevOps actually. So as the name says, DevOps. DevOps means development. Ops means operation. So the DevOps is nothing but it is development plus operations. So guys, we call ourselves as a DevOps engineer. Now the question comes, Rajesh, do we develop the application? No, we don't develop it application. Who develop the application? So the development is taken care by the developer, right? The developers will take care of developing the application, fine. But what exactly the DevOps engineer will do? DevOps engineer, basically he does most of the operations. So the collective effort between the developer as well as an operation, together we call it as a DevOps actually. Together we call it as a DevOps. So now to achieve the DevOps culture or the process, guys, we use some of the best organization. We use some of the best practices in the organization or across the organization. We use some of the best practices. So what are those best practices? That we will discuss it later. Okay, I'm just saying that we use some of the best practice in the sense, like we will use some of the best the most used tool, or the most used tool which is used across the organization. That is the best tool which we use it. So for our requirement, what we did, we follow some best practices. So what are those best practices and all? Yeah, we will try to learn about this in some time, or later in our sessions we'll learn that. But you can understand something like best practice, something like we are be using the most required tool for our project requirement. We will be using those tools. So best practice in that, it is not, but it's a tools only. So guys, we know that why we use the tools actually. So basically in the software, in the software development life cycle, we use the tools for achieving an automation. Now the question comes, Rajesh, why we need an automation? So automation is something which will make the things faster. So DevOps is nothing but it is a culture. It's a culture. It's a way where you can achieve faster delivery of the application. Faster delivery of the application. So faster delivery of the application means you can deliver or you can release the product very much faster to the market, to generally to all the public, or else you will be doing a faster delivery of the application to the end customer. Suppose you have the unique customer who wants some product to be developed, so you are developing on the request, so you need to deliver that product or that application or that website faster to your end client. So you need to follow some kind of a faster way of deliverable. And how you can achieve the faster way of deliver? By adopting a DevOps culture or by adopting a DevOps way. So how do you fastly develop it, deliver it? Because you are using an automation tool. You are using an automation tool, and those tools, or most of the tools, falls under the DevOps tools actually. So hence, what happened, guys? Why we use a tool to make the things very faster, right? That's what we use. It means that that tool will help us to achieve an automated automation. Automation you can achieve through that tool only. Am I clear, sir? So that's what I said, right? You will be using some best practices in our DevOps action. Thus, those best practices are choosing the right tool, choosing the right tool for our requirement. Actually, that is what it is. So now, what happened in industry, guys? When you are working as a DevOps engineer, one of the very challenging tasks is also to identify which is the best tool which is required for our project. That is also one of the critical tasks where some of the engineers, some of the DevOps engineers will be doing a POC. POC means actually they'll be trying to do understand the they're trying to verify, they're going to investigate on what is the tool which is required for our project requirement. And that is also that is also one of the, I can say, one of the challenging tasks in the organization, because you need to give a full proof plan on why we are using this tool, why we have to use this tool. You have to give like you have to give enough information to your senior, saying that okay, we have to use this tool for requirement, so and so we are going to achieve it. Your operation cost is going to get reduced actually. Okay, and this tool has many features, so many things you have to tell. So basically you have to do a POC, right? So when you do a POC on it, you will be able to say that, okay, this is the tool. So that's how, guys, that is also one of the challenging tasks of the DevOps to identify the right tool. Okay, fine, guys. So now the question comes, guys. Fine. Now you say that, okay, fine. We say that, okay, DevOps is something like where you are achieving the faster deliverable. Fine. Plus also you need to achieve an automation. Fine. This is all okay. So I'm using some tool, but there is one thing which is which earlier it was not very much used, but nowadays we are incorporating all the things in the DevOps, and that is nothing but it's a security. Guys, if anyone have any questions, I think some of you please mute it so that. Okay, please mute, sir, guys. And whenever, as I said earlier, whenever you have any doubts, you can ask me in between also. Okay, so to achieve this, guys, so to achieve a better way, what we are doing, that we are achieving through a DevOps tools, fine. But earlier, what happened? There were certain things which were not very much incorporated in the whole DevOps culture or in the entire DevOps life cycle, I can say. But nowadays, it has been very much used, and that is nothing but we call the security actually. So now what happened, right? In each and every stage of DevOps, actually, right? Because DevOps is nothing but it is a combination of many stages. So later we will see what are those different stages. Okay, right now we just understand that DevOps is nothing like a single way. There are multiple different steps are there. Stage one, stage two, stage three, stage four. It depends company to company. It depends upon the way you are implementing. So there could be multiple stages in your entire DevOps actually, and that multiple stages, what we say is nothing but CI/CD, continuous integration and continuous deployment or delivery. So this is nothing but your CI/CD is nothing but it's a combination of different stages we say, and this is your backbone of DevOps. Okay. So now what I'm trying to tell you that earlier, guys, very long earlier means long back, like if you ask me, Raj, around 10 years back, DevOps was there, but what happened? Security was not much concern. Okay, they used to have security, but not that much, very much, right? So, guys, again, I would request Himanshu, please mute, sir, yourself. Yeah, thank you. So security was not much concern. It's not like that they were neglecting security, but something like they used to do security at the end of the development of the application or the applications, right? At the end or in between somewhere they used to do all kind of a security test everything onto the product. Okay, so that was not a best practice, right? So later what they did, right, when the DevOps was evolved and many companies, organizations started using DevOps in full fledged. So what happened? They saw that okay, there is something which is missing in our entire DevOps, in an entire DevOps stages, and that is about the security actually. So what they did, right, in the recent years, let's say for example from last 4 to 5 years, what happened, right? They incorporated a lot of security aspects in each and every stage, of actually. And that is what we'll be hearing known as a DevSecOps actually. So in between DevOps, Dev and Ops, there is one word, key word which is coming as a security. So Rajesh, it means that for every stage, as you mentioned, like CI/CD is a common. It is nothing but what is CI/CD? Continuous integration and continuous deployment, which you said it's a backbone of DevOps. Fine, but this CI/CD it contains many stages. So it means that if there are 5 stages, or if there are 7 stages, or if there are 10 stages, do we apply all kind of a security aspects in each and every stage? Yes, we do include a lot of security aspects, or else we'll incorporate a lot of security so that the development code doesn't have any kind of a vulnerability issues. The code doesn't have any kind of a bugs, and the code which has been developed by the developer, they have used the best practice for developing that code. So all the testing of the code, development code, make sure that there are no vulnerabilities are there, no bugs are there, right? With very less bugs or with no bugs, right? And also check if there are any kind of a loopholes in your code, everything. So all that aspects are not but which is not but part of a security only. So on each and every stage of the CI/CD pipeline, continuous integration, continuous delivery, guys, we are going to discuss this in some time. So in each and every stages, we will be incorporating the security aspect, and that is what we call it as a DevSecOps. So in our course, we are going to cover even the DevSecOps also. Of course, we have to cover that. And DevSecOps has a lot of tools actually. DevSecOps process, it has a lot of tools, has lot of tools. So many of the tools, security related tools, which calls a DevSecOps tools, or primarily we call it security tools. So guys, those tools, what happened, many are proprietary tools. It means that many of the tools are being used by the organizations which are like kind of a licensing tools. Many of the tools are open source tools which are available. Even many of the organizations, they also use the open source tools also, open source. So in our course, what we're going to discuss, we are going to discuss all those open source tools which are freely available. So for those tools, there is no licensing. You can just directly take that and install it and make use of that tool. That's what we'll be using. So we'll be using all kind of a free open source tools actually. Even guys, DevOps also, the DevOps emphasize always to use the free open source tools only. If the DevOps say that okay, use some tool which are proprietary tool, so give the licensing cost for that or pay heavy money and use it, right? That DevOps doesn't really encourage. So always organization what they do, right, when they are using the DevOps best practices at their project development or at their project level, they make sure that almost all the tools what are used in their project deliverables, those tools are freely available tools. That's what they will emphasize more. If in case if it doesn't, we are not able to achieve everything, we have to rely on some tools which are proprietary tools, which are paid tool, right? Then yeah, of course we'll go with that. So, but still, what I would say that suggest that always keep in mind that when you choose for any tools, make sure that the tool should be a open source tool, guys. It should be freely available. So that is what organization looking for. That is what they will see from each and every DevOps engineer, that what kind of a tools a person is choosing to for his project. If you suggest some tool which is very much paid, very highly costly, you need to pay a lot of licensing amount for that, and also for each and every user who is using that tool, no, even for that also, like that, it involves a lot of heavy payment of your pay of the license, right? That is not recommended, and even like it is not good on your part also to suggest that tool. Always look for an alternative tool. Look for the free open source tool only, right? If there is a very much stringent requirement is in the organization there, where like, no, you can't, there is no free open source available for your requirement, then obviously you can go with the paid tool only. But still make sure that you compare with the existing free tool and with the paid one, and then like give a collective like a decision on which is the best one. If you try to do that POC and give the details to your head or to your seniors, so they'll be able to best decide, okay, which one will go ahead, will for which tool is good for us, actually, like that. Okay, so that is also one of the job or the role of the DevOps engineer. Okay, okay, guys. So now, okay, so now why we follow all this process, guys? Now you understood DevOps is a combination of many stages, and we use some best tools for that, everything. Yeah, that's all good, okay. But what is the reason behind we are adopting this DevOps culture? So the reason behind we are using for making sure that application which is running in production environment will never go down. This is what, guys, this is one of the very, very important aspect, that we use this DevOps to make sure that application doesn't go down, right? Because whenever the application which is running the production, right, always the application should be highly available to the end customer. Say, for example, you have a HDFC bank, right? HDFC net banking, or if you are having SBI net banking, you are having a Swiggy, you are having a Facebook, you are having a YouTube. Have you ever seen this application goes down? Yeah, of course, from banking application like ICICI Bank or HDFC, they'll upfront tell you that, okay, we this Sunday or this weekend we will, this application all be available because we are doing some kind of an upgrade. They'll announce it prior 1 week before, 10 days before, so that the end customer will know, okay, on this particular day and time, this application will not be available because there is some kind of upgrade going on. But whereas a Facebook or a YouTube or your Prime Video, have you ever seen this application being going down? Never, because they will try to maintain this application highly available 99.99999%, almost 0%. Hardly that application might go down just for 1 minute or 2 minutes. Even that also very much I am saying. Last year what happened, the Prime Video, right? They said that their application almost available all time, it was available throughout the year, not even for a single second or not even for 2 3 seconds the application went down. Same thing, like your what I call your Google also says the same thing, that Google doesn't go down, YouTube doesn't go down, right? Facebook doesn't go down. Your Mark Zuckerberg says that, okay, our application never goes down, right? Even in Christmas days, during, like when they are celebrating it, even that time also the application doesn't go down. How they guarantee it? Because that they are using some best practices in their production environment. That's the reason the application doesn't go down. So these all these practices, the best practice what you follow, right? That's all because of this DevOps only. So DevOps will make sure that your application doesn't go down. Okay, and it is always highly available for the end customer, right? The end customer never comes back and says that, oh, hey, your application went down, right? Because if you are doing some you are accessing that application, suddenly in between the application goes down, right? What happened? You'll be losing a customer. So customer might not be interested if your application will be keep frequently going down, or if it is not responding properly. Because if I'm using Swiggy and if I see that there is a lot of issues there in the Swiggy, I'm not able to order it properly, right? What happened? Obviously I will go and switch to Zomato. I'll have other options also, right? So in that way, what happened, right? Whenever the application frequently goes down, or if it is not properly responding to the end customer request, then what happened? Usually the user or the client will move to some other application. And this is the high market, right, guys? Where every company want to make sure that their applications are being most used, actually. So for that, they will thrive to make their application always up and add a lot of new features, so that the end customer will get attracted and he will never go out from that application, right? So you might have seen, like for example, application like Book My Show, right? Book My Show, or as the application like Swiggy, as I said, right? Swiggy and even Zomato also, right? Applications like Facebook, applications like these are the most used application across most of the clients, right? So many, even the end users, even the general public, when you ask them, go and ask them which is the movie website where you go and you can book it. They also book my show only. But there are many other applications are there, right, which are available, right? You can even book through your many other platforms are there. Like for example, you can go and book through anything. I mean, see, even I'm not able to remember now if there is any application which is apart from Book My Show. But there are there. I'm just saying. Okay, so my mind doesn't go at all because we are used to use that application. Same thing with the Swiggy, right, in India. Same thing with the Ola. Same thing with the Uber. Same thing with the Facebook, right? So we never go out from our mind. Even like for example, we all use WhatsApp so much, right? Have you seen? Sometime I have seen. Sometime the application goes down WhatsApp, right? But that's fine. Yeah, correct, correct. Right, Vedant. So how they are making sure that those applications are always available because they are following some best practice. That's the reason, guys. Okay. So guys, till here, are you okay?
Yes, Rajesh, fine.
Okay, good. Now, great. Now, so now, as I said earlier, like DevOps is something like guys where like we would be involved in doing a development, right? It means that we need to develop that application. So there is a development required. So whenever we want to develop the application, guys, develop the application. So it is basically developed by the developers. We know that's okay. In the organization, every organization, they have a lot of developers who develop the applications, right? So whenever they want to develop the application, they use certain languages to develop it. Say, for example, they use the Java language to develop. They might use a Java language to develop it, or they might use a Python language to develop it, right? Or they might use something like a Go language to develop it, right? So these are something like a backend development, programming language. We use it actually. For the front end, we use something like HTML, CSS, or what is PHP, like Node.js, right? React.js or AngularJS. So many applications are there which use for the front end development of the application, back end development of the application. So all whoever develop the front end, back end, all they are called as a developers only. And they are, and whenever they develop the application, guys, they can choose any language. There's no restriction, okay, they have to use only Java or they have to use Python only. So right, there is no restriction for that. But still, what happened in the organization, they choose, okay, which is the best language for them to use it, so they'll go with that language. So nowadays you might be hearing that most of the web applications are designed using Python only now, right? And many other organizations, they use both Python and Java together, they will use it. That is also fine. It means that an application, whenever we are developing an application, we will try to write so many models for the application. Models means we'll write a models, different models. So some developer will write that model in the Java. Some other developer of the same application, he will try to use the Python. Some other developer for the same application design, he might use a Go language. So it is possible. You can use a combination of multiple different languages actually, and yet you can integrate all those models as a part of a single application, right? You can integrate it actually. How do you integrate it? The intern use something as a REST APIs. So by using REST APIs, you can integrate many other different languages as a part of the same application. That is possible, but we are not going in detail about that because we are not really worried about like which language they use, what they use it. That is not the concern for the DevOps in here. We want only that application to be developed actually. So basically what happened, guys, the application get developed by the developer. Okay, fine. Once the application is developed by the developers actually, what happened, right? He's going to put all those developed code or the raw code into some kind of a version. You try to understand that version 2 like a repository. What is it? Something like a repository. They use a repository, guys, to store all the code actually. So now the latest what we use, what the developer used to store the code, everything, the development code is in the Git tool actually. So Git is one of the source code versioning tool, or we call it as a VCS, version code system, right? So VCS is a tool which we use. Then the tool is nothing but the Git. So Git is a tool which we use it for maintaining it actually. So once the code which is developed by the developer, he will push the code or he will place that code into the Git actually. So post that, post the developer does its job, what the operation teams will do, what the DevOps engineer will do, DevOps engineer will take that code which is there in your Git actually, and then what he will do, he will try to do something like a build activity. He'll try to do a build, he will do a test of that, he will try to even add on the security aspect. Okay, he will try to do the deployment. Even while deployment also, if you want to some security aspect, you can use in that stage also. And finally, he want to even monitor also. So guys, what happened now? What the DevOps engineer will do that? He will see how the developer is developing the code. Do you think that he will see it? No, he won't see it actually. He'll only wait for the code to be available in the Git tool. This is what the DevOps engineer will do. Once the code is available, readily available, what DevOps engineer will be told that now you can perform your operations. So what operation is performing? He will try to do a build. He will try to do some kind of a test activity. He will try in the test activity. If you want to add on some security, he'll add it. Or separately, there is some security aspect that we have to add it. Yeah, we'll add it. Okay. And he will also try to do a deployment. What is deployment means? Deployments mean installing that application, okay, that application into some environment or into some server or into some cluster, right? So we will discuss all these things, guys. So what is the deployment means, guys? A deployment is nothing but installing the application. Where you're installing, guys, you will be installing the application into the server only, or into the, we call the virtual machine, or we call sometimes that Rajesh, we install the application into some application server, or else, guys, Rajesh will say that Rajesh will install that application some. So cluster is something like we call it as a grid of many virtual machines. For example, for cluster means we have a WebLogic cluster, or else we have a Kubernetes cluster. Right? So we will come across with all these terminologies, guys. Don't worry. Right now, what you have to understand is that actually that whenever you are saying deployment, it is not, but these are the terminologies or these are the sentences we use it. We install that application, or where we install it into the server or into some virtual machine or into some application server or into some cluster. Cluster is nothing but what? It's a grid of many virtual machines in a cluster form. So those cluster is not but we will come across with some examples like WebLogic cluster, Kubernetes cluster, JBoss server cluster, JBoss server, like that. There are many are there actually. So basically we go and we'll try to go and install it on some virtual machine. That is a simple thing what you have to say. So once you install it, once you make your application up actually, and finally you'll start monitoring that application, it means that you will be finally monitoring that application, means how that application is behaving. So finally you have to monitor, and you have to even make sure that application doesn't go down. That all aspects come into the monitoring part. So now the question comes, Rajesh, you're saying that after developer has developed and put the code into the Git actually, into the Git, finally what happened? The DevOps team, who is called as an operation team engineer, he will start doing a build activity. Okay. What is build? I don't know. Okay. We will discuss about this in some time. Okay. What is test? So Rajesh, do the DevOps engineer will do all the testing activity? No, guys. The DevOps doesn't do all the testing activity. The DevOps does the testing here means just test actually. That's all. Testing and some few testing. This is what the DevOps maxi will do. So unit testing is something like where we will be doing a testing onto the development code only. It means that whatever the development code which is written by the developer, you have to run some unit test. And who write this unit test? Does a DevOps engineer write? No, sir. That is developed by the developer only. Developer itself will write the development code. The developer itself will write the unit test. Okay. Then what the DevOps engineer doing? No, DevOps engineer will just a test. He will just run the unit test cases. So once he runs it, he will get some kind of a report actually. And that report will be shared to the developer. That's what the DevOps engineer will do. Nothing more than that. Okay. So it means that Rajesh, testing, he is the full-fledged testing goes on to that application. No, sir, it will not go under this, because there is a separate team, there's a quality assurance team, or we call it a tester team, testing team. Those testing team will do a final testing of the product actually. Right? But here, as part of an operation team, whatever the testing happens, only the unit test happens and some security testing happens at this stage. Okay. So once that is done, Rajesh, what is the security? Security is all about integrating some security tool and doing some kind of a testing activity. So that's what security is all about. Okay, what about the deployment? Rajesh, you said, okay, installing that application to the end server or to the virtual machine is deployment. Fine. Monitoring is something like, okay, you incorporate even the monitoring aspect also. We incorporate the monitoring aspect also. So monitoring aspects. So why we monitor is we have to monitor to make sure that application is always available or application up and running. Okay. We also monitor the infrastructure, right? Infrastructure means we monitor the server also, whether what is the health of this server, whether it is up or not. Okay. What is the RAM memory? What is the CPU memory? Right? What is the hard disk which has been using? Or we call it disk space, how much is the percent used. So those are all monitoring aspect. And finally what happened, we'll also monitor the application also, whether the application up or not, whether the application, when a client sends any request to the application, whether the request is been responded by the application or not. That also the monitoring tool does it. So monitor tool will do many things, guys. It monitors the infra or nothing but the server. So server in sense what? Server has so many resources. Like for example, it has a memory, right? It has a, disk space or disk we say, and it also has a CPU. So to monitor all these server resources, you need a monitoring tool. Okay, and then plus you need to even monitor the application also. Like for example, you need to monitor the health of the application, right? You need to check whether the application is responding to the customer's requirement, responding to the customer request. These things, these things are taken care by the monitoring aspect. So for this monitoring aspect, we will be using a lot of monitoring tools actually. Right? To give an example at this stage only, I want to just give an example of something like we have an ELK, Elastic Logstash Kibana. Okay, this is the tool, or we call it Elastic Search. This is the tool which is highly used. Many of you have heard about a tool by name Prometheus with Grafana. Prometheus with Grafana. And of course, hundreds of tools are there in the market, guys. Like for example, you have a Splunk. Okay, we have a something known as a Dynatrace. We have a Datadog. Okay, we have a tool like App Dynamics. App Dynamics. We have a tool, something we call it as a Ichinga. Lot of tools are available. Some tools are free, some tools are paid version. So you need to go with this actually. Zabbix, many tools are there. Earlier we used to use some tool known as Nagios, very early. Nowadays people are not using this Nagios, but there are some many monitoring tools are there which are widely used across in the organization. So whichever the best suited tool which you need for your project, right? You can use that monitoring tools actually, right? So all these things, guys, whatever I said so far, it is all the things which has been taken care by the DevOps engineer actually. Guys, so far, any question? Subhash, Krishna, Saji sir, anyone have any
No,
kind
no,
of questions?
no, sir. Thanks.
Okay, so some people have some question regarding this testing. What is the unit testing and the security? No, no problem, guys. We will cover all these things in our conversations. Don't worry. There are many kind of jargon words which are being used, or many kind of words. Maybe some of might not know. They might be listening for the first time. No problem. Don't worry, because these things are repeatedly been told in every session or in this entire DevOps course, right? We will be using many of these words, terminology, everything again repeatedly. And also in every stage, I'll be describing about this terminologies to much more in detail, so that people will be get used to it. They will understand what is the terminology all about, and they will be using appropriately whenever we discuss about anything about DevOps, right? So this terminologies, everything, guys, we have to use in our day-to-day activity when we are discussing anything about related to DevOps, right? So we might have discussed some of the high availability. What is this high availability is all about? Yeah, we will discuss that also. So there are many things are there, guys. Don't worry, right? Fine. Now, so far good. Okay. Now, what are the if you ask me, what are the key features actually? Key features of DevOps. What are the key features of DevOps? So there are many key features are there, guys. One is like a CI/CD. So just a few minutes back, we heard something of the CI/CD here, right? Like I just said, right? CI/CD is a backbone of DevOps, right? So what is this CI/CD is all about? Or else I said that CI/CD is nothing but it's a combination of many stages. We call it CI/CD. Okay, fine. But what is CI/CD is all about? So this is one of the very key feature of the DevOps case. CI/CD, right? So the full form of the is it is called continuous integration, and is the continuous can call it a delivery, and we can even this deployment. So TD, we have two terminologies here: continuous delivery and continuous deployment. So what is this continuous delivery and continuous deployment? What is the difference? We will see now. Okay, we're going to soon understand now. Okay, now I always use the MS Paint, or else I will be using some latest draw here also. I will use it so that through a diagrammatic form we can understand it very clearly, right? So I will always be using some of the diagrams actually, right? Okay. Now, so guys, now we know that actually in an organization, whenever the application is developed, is it is actually developed by the developer. So you will find developers. You'll find developers. So it's not like one developer, there will be multiple developers. Suppose developer, D2 developer, D3 developer. There are n number of developers where they will be developing on that project or onto that application, right? So when the developer develops the code, what the developer will do finally, he is going to push the code into the repository, into the repository. Repo we the repo, or we call it even repository also. So usually in our case we will be using the tool which we will be using as a repository, which is Git actually. So Git is a tool which we will be discussing later, right? So now what happened, right? When the developer develops the code, when he puts that code, we use this term known as a push actually. So we always use the term known as a push. Push the code means he's actually placing that code what is there in his local laptop, the developer, he's pushing that code into the Git repository. So this is what we call as pushing the code. So many times what happens, we'll be hearing a terminology known as a push, pull, fetch. This is something we'll be always be using this terminologies when it comes to Git actually. So we will discuss all these things when we come across the Git. But try to understand that whenever we want to push the code, we'll put into the repository. Whenever we want to copy that code from the repo, we call it a pull actually. Pull or fetch. So you can either fetch the code from the repo or you can pull that code. So we use these terminologies, right? And when the developer push the code, right, what happened, right, into the particular source code version. Say for example, the developer is developing the okay, he will keep the source code version as something like a something like S1 something code, right, and also what happened, that is the source code actually, right? Assume that, and whenever we are pushing the code into the repository, we usually give some kind of a versioning. Say for example, as V1. So it means that this is my first push actually. So suppose assume that the D1 developer, he pushes the code, okay, and he will give the code version as V1. Say for example, if the D2 developer, he writes some code and he want to push the code into the repository. So what he will do, that he will have the source code S1 only, he will give. So whenever guys, whenever we are pushing the code to the repository, we will tend to give some version, and that version whatever we're pushing, it should be higher than the existing version. That is what the we follow the practice, that whenever we are pushing it, it has to have some version. So assume that D1 has pushed the code, it will be version 1, D2 has pushed the code, it will be version 2, and D3 developer has pushed the code and it is called as a version 3. Am I clear, sir? Is it fine? So we're pushing the code. Now the thing is that guys, now here, when the developer one, say for example, when the D1 developer, he pushes the code, consider that the push as P1. And what is the version of the code he has pushed? He has pushed the V1 as a version of the code, right? So now guys, what you need to perform, the DevOps engineer has to perform that, you need to build that code. You need to test that code. You need to deploy that code. And even you need to follow all security best practice in the in your requirement, in your this one. And we need to even not monitoring, up to here we have to do some operations actually. Okay, so whenever any kind of a push happen to the repository, what the DevOps engineer will do that he has to build the code, test the code, deploy the code or deployment or and also you have to add on some kind of a security aspect. So what I would suggest that even adding the security aspect, this much is what a DevOps engineer will do actually, right? Similarly, if the D2 developer, he is pushing the code, he's pushing code, new code, and his push considered as and what are the version he has developed, he will give the what DevOps engineer will do. Again, he has to do a build of that code. Again, he has to do testing, and if there is any security aspect, add on that security aspect into it. So, guys, on each and every time, whenever a new version comes into the picture, or whenever the developer pushes the code with new version or with a new version, what DevOps engineer has to do that he has to do some kind of an operation. What is that operation? You need to build it, test it, or collectively you can say build and test it. He has to do it actually, right? So what happened, right? Doing everything, all this process is a tedious task. So if a DevOps engineer, if he follows a manual way of doing this, manual way, he said, Rajesh, DevOps engineer, he'll do manual everything, man. He will try to do a build activity, he'll try to do a test, he will try to even add on some security. For every push, if it does manually, it is a time consuming. It's a tedious task. Right? Suppose that there are 100 developers are there. They will push all the 100 times they'll push it. Do you think that DevOps engineer will sit and try to do all the operations manually by 100 times? No. You need to have some automated way of doing it very much faster. You cannot do it everything manual. It is very, very tedious task. Hence, what is happening that we will be using some tool for doing all this operation. What the operation? We need to do a build, we need to do a test, and we need to add a lot of security aspect into it. Right? So we will be using some kind of a tool actually. So Rajesh, what is this all about this tool actually? Right? What is this all about tool? So what is this build is all about? So guys, build is something we call it as a, I can say it as something like a compiling the code, in the code, right? Or else we call build the code, building activity. This is all together is called as a build actually. And this build can be performed, or I can say build will be performed using some tools. Say for example, we will be using some tool as a Maven tool. So don't worry, guys. This Maven tool and all will come across in some days, not immediately. Maybe after 15-20 days, we will come across this Maven tool. So Maven tool basically, guys, it is used for build activity for your Java code actually. Okay. There is one more tool is a Gradle tool. The also for building activity. There is some tool is a make tool. Make tool is also used for building a C and C++ code actually. So what this tool does, Maven tool, Gradle tool, Make tool, many tools are available, Acto tool, lot of tools are available. So what they do that they will try to build that application. What is building the application? Rajesh, we need to compile the code. Okay. So guys, can I know what is the compiling means from you, from the audience? Can anyone tell me what is compiling means? Anyone, whatever thought is there, you might just tell it. No problem. If you're wrong also, that's fine.
Find out the
Onboarding.
syntax, others.
Uh-huh. Okay, good. Fine, very good. So now guys, what is compiling basically means basically, say for example, if you done a code in Java language, right? So when you're writing a code in a Java language, basically what happened, you will be writing the code in the Java, plus you'll also be using some kind of a dependency for your requirement. Okay. Okay. And also like some kind of a library, combination of dependency tool or dependency library, plus many of the other using to develop a code. Now, once you develop the code, this developed code, which is Java, it will be in a high level language actually. HLL, we call it a high level language. So, what happened, right? Whenever you are building a application, you will be writing a high level language that is Java program. Once you write a Java program, you cannot take that raw code or you cannot take that high level code and run in the machine. You cannot run it because your machine cannot understand your Java program. Hence, what happened that the Java code has to be compiled into machine learning language or machine understandable language. Mul we say mul, or else it should be in a what can I say, it should be in a I can say machine. It should be in a machine understandable or it should be like assembly language something. So whenever a compiled code is in a machine understandable language, or when it is an assembly language, then only your code will get run, code execute, right? So this process of compiling the application from the high level language to the machine understandable language is done by a tool actually, and that we call a build tool. So for example, for building a Java code, we have something as a Maven tool. Earlier there was a tool, is an Ant tool, Ant tool, but Ant tool had some disadvantages. To overcome that, Maven tool was came into the picture, and Maven does all kind of a compiling, build activity, creating package, everything for all Java related applications. Right. So you have seen that, like, we have a mobile phone, right? Android phones. You know, in the Android phones we have so many front end web apps we install it, right? Earlier, most of the apps were designed by the Java language only, right? Later, what happened? Many other languages came, which by using that you can develop the application, mobile app application. But still, most of the existing application or the existing Android apps, right, are still written in Java only. So once you want to make that application up and running, you need to build. You need to build means you need to compile it. So compiling has various stages, which we need to really get into detail. Compile is something like where, okay, where what compiling intern will do that. So for example, Maven build, what it will do that, Maven build tool, it will compile the code. What's the process of compiling means? Compiling, what it will do that, whatever the Java code which has been developed, what it will do that, it's going to check that, okay, if there is any kind of a syntax thing which is written by the developer. If he has written any kind of a wrong syntax, it will check it. Say for example, somewhere mistakenly he has put comma which is not required in the code, right? Somewhere he might have not used the proper keywords. So there is a way of doing some kind of a synthesizer checker, we say synthesizer checker. So the synthesizer checker plus syntax check and so many other checks is done by your build tool, Maven build tool. Once the compile stage completes, it means that the code what the developer has written logically and without any kind of a syntax or everything is fine, then only the Maven build will compile that code. So once the code is compiled, you will get kind of an object file. So once you compile the code, finally you will get something we call as an object file. So I'm telling it a very high level, guys. Object file. That object file will be added with your dependency or library, you to get a Java program. Say for example, suppose I have written something like a dot Java application actually, right? So what happened, right? Once you compile the code, you will get a file by name a dot jar file, something like this. So this a.jar file is an executable program. Is an executable program. Similarly, if I return any program in a.c in the C language, after compiling it, I will get a.out program. That a.out is an executable program. It means that you can run that program. Whenever you get an executable file, right, that will be understood by your system or by your operating system or by your processor. So then only it will try to execute that program. So guys, whenever a developer writes a code, you need to first build a code. After building a code, you can run that code or you can run that application. This all process, everything we call as a build actually, right? And in DevOps, whenever we try to build it actually, whenever you try to build it, when you try to do a build process, we are going to get an output as a package actually. So that package can be a jar file, it can be a war file, or it can be a zip file also. It could be in any format actually. It depends upon the way you are building or you are packaging, right? So we will come across with all this terminology again. What is packaging is all about what is build. So as I said, build is something like we are building a package or we are coming up with a package. The output will be package. And what kind of a format of the package it is all .jar file, .var, .er file or .zip file or a.out. It could be in any format. That depends upon the end user requirement. Suppose I want the output to be a jar. I will make when you are building it, I will make sure that a jar file have to get it as an executable file. Similarly, if I want to have a var file, .var file, I'll make it as a .var. Similarly, .er. Similarly, .zip. Whichever way I need, I will able to give that as an input so that the build process will give me that particular executable format for me. Is it fine, guys? Now the thing is that now coming back to here, what I said actually that because there are multiple developers are there who will be keep pushing every day, they will do 100 pushes. You need to do 100 times the build activity. 100 times after the build is done, you need to do some testing activity. You have to check whether the code what the developer has written is fine or not. It means that you will be running some kind of a unit test cases. If the unit test pass, it means that whatever the code which has been developed by the developer right? That code is fine. There is no vulnerability. Sorry, there is no syntax error in that code. The code looks good. So that's what you need to verify and test it. If the unit test fails, you will get back to the developer saying that, hey, the testing has failed, man. Try to please recheck your code. You have written something wrong, or there's some kind of issue might be there. So the developer is going to recheck the code. He's going to fix the issue. Again, he's going to give one more code. It means again he's going to push it, so that you will start doing all this build activity. So guys, what we are doing here as a DevOps engineer, we have to do a continuous integration every day. So continuous integration has to be performed every day. Continuous integration. So continuous integration is what, guys? Now you understood that continuous. Rajesh, we need to do a build. You need to do some kind of testing, as well as you need to do some kind of security aspect, right? So we have to do it. Why you have to do it? Suppose, for example, a developer D3 has given a code. He has pushed the code into the Git. He has given a code. He has pushed the code into Git. After he has provided to Git, the developer will contact our DevOps engineer. What he will say? He'll ask. A developer will ask, "Hey, Rajesh, you're a DevOps engineer, right? Have you built my code, man?" He'll ask straight away. He'll ask within 5 minutes. He'll ask. I'll say yes. The build is available. Yeah. Can you please share me that build? I have to perform some operation. You need to readily give him. So it means that whenever the code is pushed to the gate by any developer, he will be eagerly waiting for it to be built actually. It to be built, so that the build is available. It means that the build code is ready to be deployed. It is ready to be deployed to the server. So once you say that, yeah, the build is ready, it is available, then the developer say, please go and deploy it. Please go and deploy it. Go and install into the server. Go and deploy into the cluster. Go and install to the VM, or go and install into the your Kubernetes cluster. He can tell anywhere, wherever it is getting deployed, right? He will tell, go and deploy it. So you have to go and deploy it. Once the deployment is done, now you will give a report saying that, okay, now the code is deployed. Now the code is up and running. Yeah, now it is available. Now that application is available. This is what a very small process where the DevOps engineer will do. So now, guys, this is something we call as a continuous integration. Am I clear on this? Say, guys, yes or no? If I've understood.
Yes,
Yes.
Rajesh. Yeah.
Source file to the executor file is nothing like compiling or else building. Yes. So guys, you might hear this terminology a lot: compiling, building, packaging. If you ask me very specifically, all these terminologies are one of the same: build, packaging, compiling. But in our DevOps, right, we never use this compiling. Actually, we don't use it. Basically, we use either as a build or we call it a packaging. So what is a packaging? Basically, packaging is an output of the build process. Once you give a build to the Maven tool or to any tool, the output of that Maven tool will be as a package. Okay. So Rajesh, is this package also something like executor format? Yes, sir. Build is something like it's a raw code. It's just a code. It's a code what we have picked from the Git, what the developer has pushed, right? That code will take it as, we'll use the terms of build, and once the build is applied, you will get an output of a package actually. Right? And that could be in any executor format. So again, there are different kind of execute formats are there. We call those as an execution domain. What we call? We call the execution domain. These are all guys, whatever we are this one, this actually, all these things, we call this as a execution domain, executable domain or execution domain we say. What is it? We will see it later, guys. This is a fantastic thing to understand execute domains, right? These things we will discuss in detail later. Okay, fine. Okay. Okay, fine. Rajesh, what is this security is all about? Can you tell me something more? Yeah, we will discuss that more, sir, in some time. Not immediately, but I will tell about what is the security aspect later. Okay, fine, guys. Now, usually what happened, what industry will do basically, guys, right? So now the developer is there, he will push the code into the repo, which is number the Git. Okay. So once he pushes, do you think the developer will always go to the DevOps and say that, hey, now I push the code, man. Check, the code is available now. So suppose the developer is doing 100 pushes. Do you think that he's going to tell to the DevOps 100 times, yeah, push the code, I push the code, or whether he'll ping in the chat message or into the Teams, so that Rajesh, have pushed the code, now you do your operation. No, right? They never say it. They never communicate like that. So whenever the push is done to the Git, there has to be some kind of a process, okay, or there is something which we call it as a webhook triggers here. So what is a webhook triggers? We will see later. Don't worry now. I might be using some lot of terminology, guys. Some of you are aware, some of you are not aware, but still just try to understand it. I'm introducing all these things at the very beginning, but don't worry. So what this webhook triggers does, basically what happened, you will configure this webhook triggers onto this Git repository. So it means that something a monitoring will happen. So what happens that whenever a developer push the code to the gate, this webhook triggers is going to trigger some kind of an operation automatically. So what that operation will do that? So who will configure this webhook triggers? It is configured by the DevOps engineer only. So what he will do, he will go to that particular GitHub repo, okay, where the developers are pushing that code into the particular branch or into the particular repo. So there what happens, they will configure these webhook triggers. And what this webhook trigger will do, that webhook triggers, what happened, it will point to something we would have written something. I mean, I'm just saying in a very high level, some automated scripts have been written. So what the data script will do that it will try to do all this operation, build operation, it will try to do. So build operation like this, like build. We know now that Rajesh, what is build means? Build is something like where you will be compiling the code, you will be testing code, test the code or unit test. You will be adding some security aspect, right? Right, like this. Okay, and also like you will be doing something about building. All these things is been taken care by that script actually. So it means that Rajesh, automatically whenever the code is pushed by a developer, we need not to worry because we have added a webhook triggers. That what it does, that what happen, it will trigger the script, and finally this script will try to call this build activity and it will perform this entire build activity. So when it performs the entire build activity, finally you will get a package out of it actually. And how we are doing all these things with the help of this something we call the continuous integration. So why we are doing all these things, Rajesh? Then, man, you makes very faster, right? Why we are doing all continuous integration, guys? Why you are doing all this continuous integration? Why we are doing all this continuous integration? We are doing this continuous integration to achieve the things moves very much faster. To make the things very faster only, right? In the organization or in the industry, you cannot do everything manually because there are so many tedious processes are there for doing all this, for all this continuous integration, for all this build activity. It's a tedious task. It's not that simple. Some of the builds, I mean, if I tell you, right, the application will be huge actually. You will be using a lot of dependencies and everything. Sometimes the build activity will take 15 minutes of time or 20 minutes of time. So you need to sit in the front of a system, wait for 20 minutes, check all the stages of the build, whether it's going or fine or not, and finally say that, okay, now the build is completed. Some builds are very, very faster. It will just do build within some 20 second, 30 second or 10 second. Some builds will take more and more time. So it depends upon the application and the design it has been designed, and it depends upon the complexity of the project because when the developer develops very complex project, right, they will write a lot of codes, they will write a lot of models. So obviously what happened, dependencies also will increase, usage of the shared library in their projects also will also increase, and finally even compiling also or the build also will increase. So what I'm trying to tell that there are many complex stages are there where we will be involved in doing while build activity to make it very, very easy, smoothly what happened, right? We will try to follow this continuous integration way. And why we are doing that? To achieve everything in a faster pace so that the build is readily available and we can take that build and deploy into the server. This is what you have to do. So once the continuous integration done, what we do, guys, once the continuous integration is completed, we will try to go with the deployment. And the deployment is nothing but it is a continuous delivery, or we call it a CD, right? So once we completed this continuous integration, we do a continuous deployment or continuous delivery. Now, what is this difference between the continuous delivery and the continuous deployment? So guys, this is one of the very important question. Though it's simple, but we all have to know about what is the difference between the continuous delivery and continuous deployment. Okay, let's see now what is the difference. Okay, let me check. Somebody asked the question. Guys, I would always request that please don't put any kind of a question. Yeah, thank you. Okay. Please always unmute and ask the question. It is always a right way to, to discuss, to have an interactive session in the class. So I would always humbly request to everyone. Okay. Now, the thing is that, guys, now, so what we understood, Rajesh, a developer pushes the code. We know that he will push the code into the repository. Okay. So guys, we are discussing about the continuous, we are discussing about the CD. Oh, sorry, I think I have to decrease it. So we are discussing about the CD, right? So what is CD means? It is continuous delivery or continuous delivery. So there are two things are there CD. So one we call it as a continuous delivery, and other we call it as a continuous deployment. Both terminals are used. Okay. Now, so we learned that okay, when the developer develops a code, he'll try to push that code into the repo, some repo, and that repo is nothing but the repo. We have seen now. Okay. So Git, what is Git, Rajesh, all about? We have a separate session, guys. Don't worry. Once our basics completes, we'll be getting into Git, and Git has a lot of things. So we all have to know Git very well, right? So once the push code is pushed, what we do, guys? We will try to do a continuous integration. Do you agree with me? The next process, what we do is I think I'll show it. Okay. What is it? What we do? We call it as a CI, continuous integration will do, right? So it means that, so once the continuous integration done, it means that the build is ready. Build is ready. It means that you have achieved the CI part, the build is ready. Right? Once the build is ready, guys, what we do basically, we will go and we will try to do something known as a continuous deployment. After the CI, we have to achieve the CD. This is what the process is. So now what we're doing that CD, there are two CD are there. One we call the continuous delivery and another is a continuous deployment. Right? So now, right. Now, what is a continuous deployment? So continuous deployment is something like where you will achieve the complete process. So since from the time when the code is pushed to the gate, okay, automatically the CI will get completed, automatically the CD will be done. Continuous deployment is something like continuous deployment is something like where you have certain targets to be target server to be deployed. Say for example, for example, I'm just saying, for example, Rajesh, I have a Kubernetes cluster. This is my Kubernetes cluster. So what is Kubernetes and all, guys? Go, don't worry. I'm just saying that this is one of the I can say one of the cluster where we deploy the application. So assume that this is your Kubernetes cluster. So what the CD will do, basically it will take your build, whatever the build you got or whatever the package output you got, right? It will take that build and it will try to go and deploy it here into this Kubernetes cluster. Okay. So now the thing is that as soon as the developer pushes the code into the gate, automatically the CI is done. After the CI is done, automatically the CD will be done, and finally the build will be deployed to the Kubernetes cluster onto or into some application server. The entire process of doing it automatically without any manual intervention or without any human intervention, the whole process we call it as a continuous deployment. Continuous deployment. It means that the code is available in the kit. Once it is available, the whole process till the application is getting deployed to the target server or to some cluster like Kubernetes cluster or WebLogic cluster or whichever cluster might be or whichever application server might be. So the application is available or installed into the end customer server and the application up and running. This whole process of doing it, if you are doing it everything automated fashion without any human intervention or without any manual effort in between, without any manual efforts in between of this entire process, that whole thing we call it as a continuous deployment. So continuous deployment is completely an automated fashion. It's an automated way. Okay, it's an automated way, right? So now a question might come, Rajesh, do all the industries follow this continuous deployment? Because there's no human required, right? When the code is pushed, you need to build this CI/CD pipeline or but CI/CD backbone where everything will get automatically and finally the application will be deployed into the end cluster or into the end server, right? Which whatever you have chosen, right? It is deployed. So this is an automated fashion where every organization practice it. Yes, sir. Most of the organization practice it, right? But the thing is that not every company will be able to achieve the continuous deployment. Why? Because that there is some kind of a manual effort is required or human effort is required. Say for example, when you are trying to do a CD part, the continuous uh, deployment part, right? In many of the organizations, when you're trying to do a continuous deployment, there what happened, right? You need some kind of a manual efforts. So manual effort in sense, Rajesh, what it means? It means that, sir, when the code is comes to the gate, suppose the D1 developer has pushed the code into the gate. Now what happened that code will be automatically a CI will be done. Once the CI will be done, it will not be pushed to the continuous deployment. Here what happened? Some kind of a manual effort is required. It means that some kind of an approval is required. Some kind of a check is required. You have to make sure that CI has been completed properly without any issue. So then only post approval by the management or by some senior architect or by some team lead, what happened? He will allow it to, he will make it approve. Once the approval is done, then only the CD part will be done. Then it means that the continuous deployment is done. The deployment is done. So here, what happened that you are not achieving complete automation here. There is some kind of a manual effort is required in between, so that you need some kind of an approvals from your stakeholders or from your seniors. Then only the code will be deployed finally to the cluster. So this is what we call it as a continuous delivery. Continuous delivery is a manual way of deployment. Deployment can continue manual way of doing a deployment actually. Now the question comes, Rajesh, if everything is automated, that is good, no? Because you have to go and install into the target server. Why you want to do all this manual way of doing it, man, in between? Why you're stopping? Why you're actually breaking that cycle then? Then what is the use of DevOps then? Yeah, that's all correct question what you might be thinking. But to answer this question, I will discuss a few other things so that you will get a complete answer. Okay. So now, guys, what happened, right? The thing is that actually that many times what happened, right? In most organizations, still what happened, the end deployment of the application into the target server or into the targeted cluster, it still happens manually. There is no automated fashion. It means that you will not be doing a complete deployment of into this Kubernetes cluster or into the end server by using a completely automated fashion. It has not been done by all the industries, right? Only fewer industries are the where they do a complete deployment, right? Where they completely achieve this automated way. So which are those industries? Companies like Facebook, companies like Amazon, companies like Microsoft, companies like Misho, companies like Netflix. These big companies, they have adapted that culture of doing everything automated fashion, even in the production environment, even into the production world. But many of the other organizations, like for example, a company who's developing the e-commerce application, companies who are developing a banking application, companies who are developing some healthcare application, they cannot achieve the complete deployment into automated fashion because they need some kind of a pre-check. They need some kind of an approvals. Some seniors have to check all these things. They will not allow the application to be deployed to the production environment, guys, unless and it has been approved by many of the managers or many of the stakeholders, because it's a risk actually. There's a lot of risk factors happens if you are deploying it directly to the production without having without the checkpoints from the stakeholders or from the seniors actually. That is what happened. Many of the organizations who are developing e-commerce applications, right, heavy big e-commerce application or heavy financial or FinOps applications or banking applications, there is no complete automated way. They will not be able to achieve it actually. That's what happened, right? When you're doing the CD manually to the end target or end server, that we called as a continuous delivery because there is a human intervention has come here into the picture. Am I clear, sir? Dipali, Rajiv,
Yes,
Naresh?
sir.
Yes, Rajesh.
Yeah.
Yes, sir.
Now, yeah, that's okay. It's good only, but still, still what happened? Like there's a manual effort, I understand, but then where we are achieving faster? Because see what happened. No, when you are developing such huge products, big products, where you need to manage a lot of things, it actually there what happened? You are not really worried about faster deliverables. You are worried. You are concerned more about that the application, whatever we are releasing or whatever we are deploying to the into the end server, right? That application should work fine. It should not break it actually. That would be the more concern rather than the faster aspect actually, right? Industries like banking sectors, they're not really worried. They don't want everything continuous deployment. They don't want it. They want the process to be faster, very much fine. Till here, CD, they are okay. CI, okay. But CD, what happened? They will discuss. all stakeholders involved. And funny what happened, they'll choose that particular time and date, and they'll say, oh, now we will go and deploy that particular new version what the developers developed it. Okay, so they will take care of it. They will make sure that the application is properly deployed, tested, verified. Finally, that newly updated version should be available in the target server. So many testing also they will do it, verify it, and check it everything. So a lot of precautionary action has to be taken it actually. So similarly for the fintech operations or financial domain operations where they will be running a lot of financial related applications, right? There you will do it, right? Say for example, companies like Netflix, where what happened now, they are only developing a Netflix actually, right? So Netflix, all the application what is been designed, right? They use some strategy knows that they developed as a microservice. And managing the microservices, deploying the microservices into the end target server into the Kubernetes is quite easy. And recovering back, suppose if they're developed, deployed into the production, but assume that there's some failure happened, they'll immediately recover back also. Very immediately, within a fraction of a second, they'll recover back to the previous version. So those things are very much faster if you develop the application in the microservice architecture level, and if you deploy it, you can achieve the continuous deployment. So that's the reason companies like Facebook, Amazon, Netflix, YouTube, Gmail, they will do a faster deployment in an automated way because they have already adopted the microservice architecture. What is microservice architecture? We will see in some time. Okay, so guys, so what I'm trying to tell here that there are two ways are the one is an automated way, other is a manual way. Manual way is something which is a traditional way of things doing deployment. So when I worked in all my previous organizations, let it be Lumen where I worked for 10 years, we use everything automated manual way only, no automated there when it comes to production. Right now, why we are doing all these things, Rajesh? What is there any story behind with this? Yes, sir. There is some story behind this. Let us discuss now. What is that story? So, guys, I hope that you understood the context, right? Right?
Yeah.
Okay.
Yes.
Now, what happened, guys? In an organization, what they do whenever the application is developed by the developer, right? Usually, what happened, right? We try to create some set of environments. We say, what are those environments? We try to create some environments. What are those environments? So you might have heard some the Dave environment. You might heard something test environment, or we call it a QA. We also heard something known as a PPD environment, pre-production, or we call it as a stage environment, and we call it as a prod environment. And also we have one more environment we call the disaster recovery. So these are all, guys, these are all the different environments where each and every company has. Some company has more than this environment. Here, how much is the one, two, three, four, five environments are there? When I was working for the DXC company, right? DXC, the project which I was working on, basically it was a healthcare project. And that project, basically we had around 12 environments actually. I don't want to name that environment, but it had 12 environments. So it was fantastic. So why they have so many environments? There's a use case for that. It depends upon company to company, project to project case. You cannot say that you should have only 5 or 3. Some companies has only 3 environments. Some companies has 6 environments. Some company has 12 environments. So basically, these are the very minimal environments where each and every company follows actually. Yeah, UAT, yeah, stage, all are same actually. Yes. Okay. PPD means pre-production. Post-production on but prod we say. Even we have post-production also. That usually some companies have that, some company doesn't do that. Okay, this is a pre-production, post-production, and prod, right? And disaster recovery, right? So now, why we have such environments and what is the use of so many environments what we have? So when the developer develops the code, right? So what happened that once the code is developed, developer has to test the code what is written, guys. So what the developer will do basically that the developer, oh sorry, the developer develops the code, right? He need to verify the code what he has written. So he needs some kind of an environment. So hence what happened, right? This a Dev environment will be there. Dev environment we call it as a very environment. We call the lower environment. We call it the lower environment. And usually what happens, the developer what he will do that he will take into this Dev environment and he will try to deploy the code and test it actually. So testing means he will test his code, whether the code has any kind of a syntax error, whether the code is able to run or not. He will do some basic testing. So many operations where only the developer will do it for himself to verify it actually. right? To verify the initial code what is developed, right? Whether it is working fine or not, he need an environment. So the environment will be built actually. The environment will be given. So what is environment means you can consider as a collection of some infrastructure, guys. So what is environment means, guys? Collection of some infrastructure, right? What is infrastructure means? Rajesh, for my development, I need some virtual machines, man. VM I need, virtual machines, okay? I need some storage, okay? I need some network, okay? What else you need, guys? Apart from that, I need sometime I need even I might need a cluster also. Okay, I need some kind of a configurations also. I need to configure it. So you need a various different aspect together, various different infra thing, as well as some kind of a configuration is required so that you create that environment with the help of some infrastructure and you try to do all kind of a development activity. So we take a development activity that we will take this environment, we will take the virtual machine, we will try to install some software stack what is required, and on top of the software stack we will try to take that code, install that code, build that code, install it, and finally test it, verify whether it is working fine or not. So that you can achieve through the environment only. So basically you can say that Rajesh, is environment is a hardware requirement? Yes, it's a hardware requirement. Plus it also has a software stack also, plus it has some configurations also. So many things together we call it as an environment. So every company has this environment, right? Build actually. Now the next question comes, right? Who is going to build this requirement or who is going to create these environments? So again, these environments are created by the DevOps engineer only. Okay. So Rajesh, the DevOps engineer has the access to the dev environment. Does he have all kind of permissions, everything in the dev environment? Yes, sir. Because he has created it, he has it. Apart from DevOps engineer, who has the developer? So developer and the DevOps engineer, both of them have the access to the dev environment. Okay, fine, good. So what about the test, Rajesh? Why we need to create a test environment? Yes, once the code is developed, guys, once the code is developed, you need to do a lot of testing activity because whenever the developer develops the code, when the code is developed in a very full-fledged form, it means that lot of all the features of the code of the application have been developed now. So at the end of the stage, actually, what happened that you need to do a lot of exhaustive testing you have to do. So in an organization, there are QA engineers are there, quality assurance engineer, or we call it testing engineers. What they do that they'll take the developed code, they'll try to build it, and they'll try to deploy that, and then they have to do a various testing aspect. Like they want to do a basic testing, test testing, stress testing, penetration testing, operation testing, right? Security testing, network testing. So many testing strategies has to be adopted onto the product, or they have to run that so that we are going to check whether the product is in a very highly stable state. If the product is very highly stable state, if there are no vulnerabilities issues, the code is working fine as per the client requirement, then we say that the product is ready to be released to the market or to that end customer. So we need to follow some testing aspect, or we need to follow a testing strategies actually. So who does all this operation? Usually in organization, the testing will do it. So for the testing, again, you need a different configurations, right? You need a different environment configurations you need. You will say that Rajesh, in one testing environment, I need to have two nodes I need to have, right? And I need to have this much storage. This is the kind of network I need. Okay. In another testing environment, I need more than three servers, which is clustered together. One server will have high CPU, one server will have low CPU, one server has more number of storage, more storage is required. So you will have a combination of a different testing environment also. So why we do that, or why we create that environments? Because guys, when we give the product to the end customer, we don't know what is the environment we will be running that application. He might be using a lot of CPUs for requirement for his. He might be using some kind of a configuration where what happened, he will try to take that application and run it. So we don't know upfront what kind of environment in which the application, whatever we are developing, that application will be running into the client's production environment. We don't know. So hence, to test all the aspects of, we will have a different testing environments. Like for example, you have test 1, test 2, test 3, E2, like this we'll have. Test 1, test 2, test 3 environment, E2 environment, means end-to-end environment, we say E2E. These are the different testing environments you have. So again, the question comes, right, who will create all this environment, Rajesh? Test 1, test 2, test 3, E2E. All these things are created by DevOps engineer. Okay, now, so all this environment, Rajesh, who will have an access? So, sir, DevOps will have an access to all this environment because he only created it. He is also one of the co-owner of that environment. Testing engineer will also be a owner for this environment, even the development to some extent also the owner of the test environment. All the three people, DevOps, testing team, as well as the DevOps engineer, all these three people will have an access to this test environment. Okay. What about the PPD or the stage? Yes, this is also one environment. So before getting into PPD, let us understand what is this prod. So guys, prod environment is something where your finally your application will be running under the production environment. So this, whenever the application runs a production environment, it means that your application is lively available to the end customer or to the general public, so that they can access that application or they can make use of that application. So once the application comes to production environment, it is available right to the end customer, right? So you will be having certain environments for the prod. Obviously, prod environment will be a higher, the configuration of the prod will always be higher than the day one the test, because day one testing is something where we will try to create with a very less configuration of all these hardware requirement. But as a prod will have a very lot of high resource requirements will be there for the prod to build actually. So hence the DevOps engineer will also build a prod environment with a very high configuration, with large number of virtual machines, more number of storage, more networking, complex networking is involved in that. Okay, he might be using a lot of big configurations things for coming up with this prod. So all those things, guys, what happen? The DevOps engineer will build the prod environment. So now, once the prod is developed, actually, right, they will also come up with one more environment, known as PPD, pre-production, or the stage we say. So why we have these two actually, basically, guys, this is something like before we push to the prod environment, we need to verify finally the developed code whether how it is working fine in the PPD environment. So before we push to a prod, we have to verify. One time we need to verify it actually. Who has to verify? The testing team has to verify. The DevOps team has to verify, and even the developer has to even sit and check it whether how the application is running in the pre-prod environment. So once they are satisfied it, then only they'll try to take that same code and push into the prod. So it means that Rajesh, is the PPD is the same as prod environment. What are the configuration you have used? Yes, sir. These environments almost both are same actually. It means that if whatever the so whatever we have a prod environment, the same configuration is there in the PPD, guys. PPD environment or the stage or the called the pre-prod, right? And also what happened here at this stage of or at this environment, we'll also allow the client to interact with the application. Suppose your client has given a requirement, you are developing some health application for your client. If client want to see how you have developed it and all, he will be shown all the demo in the pre-prod environment or into the stage environment. Here what happened, client will lively see how that application is behaving, how it looks like, whatever my requirements are, that it is satisfying you or not. Or even at the moment where the client see it, he might even request to do some modification into that application. So if you have a time, okay, even you can incorporate that small changes, whatever the developer has whatever the client has requested for you, even you can change it. So here this is a stage where, or this is an environment where you will allow your client to interact with your application, with the developed application, and he will go through it. He will finally say yes, right, it looks good because whatever I needed, everything is perfectly there in that application, everything works fine, I'm happy with the developed code. Then finally, with his approval, what happened, and with our internal stakeholders, everyone, we will try to take that code and we'll try to finally deploy into the production environment. So since the production environment is available, I mean, you have deployed the application, that application will start be used by your end customer, right? So now after this, what happened, you have one more environment because of disaster recovery. So guys, always what happened, prod environment, you will always be up and running, right? But sometime what happened, right, maybe sometime there might be some kind of a issue happen where the production server might come down, or where the application which is running in the prod might go down. There might be some kind of a crash might happen, there might be a network crash happens, there might be an OS crash, or there might be some disk crash or storage crash happens, or the whole operating system will get crashed actually. It can happen actually. But at the same instance, what happened that if your application is being used by the client, and the client is happily using your application, suddenly all this kind of a disaster happen. What happened, right? The client will see a downtime of that application. So client will get a void message saying, oh, the application is down, or he'll get something like a like 404 error, something like that. He will get where he will see that the application has gone down, man. Suddenly it has gone down. So, but what happened? You need to have a mechanism where what happened that you need to immediately give the service to the end client. You should not see him. You should not see that your client will complain say that the application is down. You should not be in that stage. So immediately what we do that we will try to even build a disaster recovery setup actually. So what the disaster recovery will do, that disaster recovery will have the same setup as a prod environment. As soon as the prod goes down due to some reason, this disaster recovery will be activated and will start giving the service to the end customer, so that the end customer doesn't see any kind of a downtime. So during that time, when the disaster recovery get activated, during that time what happens? The DevOps engineer, the developer, and many other stakeholders, they will be active and they'll try to find out the root cause of what went wrong in the production environment, why the application went down. So all those things they will try to do an RCA, and then they try to fix that issue, and finally they'll make this product up and running. So that is what happened. It is like a I can say that it is like a timer for all the people, because as soon as the product went down, what happened, right? There will be an immediate action happens, right, where you'll start coming up and we'll start checking out in the production moment why the things went down, right? So many checks we will do. You will have a lot of bridge call everything between among developers, DevOps, and testing, many other engineers, stakeholders, and you will verify, check it, check logs, check all the logs, everything, and finally you will see that okay, what went wrong, you'll fix it and you'll make it up actually. Okay, so now, so this is all the environments, guys, we have it in the organization. Okay, many organizations doesn't have this DR. They are still setting up. They know the importance of what is DR is all about, right? They are still doing. Some companies already have a very perfect DR, disaster recovery setup in their organizations, because they want to maintain it. Sometime what happens? Some client might specifically ask to you that please also set up the DR also, right? So that we don't want to use any kind of a downtime. We don't want to have our application down, or we don't want the data to be lost by the end client. So those things and all we shouldn't see in the future. So hence please build the DR. So DR setting up and make sure that DR get activated immediately. That is just like a plan, guys. So we will try to even discuss that also later. Not immediately. What is DR? How do you set up a DR? And where do you set up it? What kind of a configuration you do it? And how DR become active? That is very interesting thing which we'll be learning in our near future actually. Not immediately, but in the near future, right? So guys, usually what happened, this dev environment, this test environment, this we call the lower environment. Even to stage also we call the lower environment. The high environments are prod and the disaster recovery. These are high environments. Now the thing is that, guys, what happens that in this dev environment, test environment, and the stage environment or PPT environment, you can divide like this. This is the lower environment and this is a higher environment. Lowest environment and higher environment. Usually what happened, right? We will adopt here the continuous delivery here. Suppose you are continuous deployment here. So in a lower environment, we always achieve this continuous deployment. What is continuous deployment? It's an automated fashion where when the build is pushed to the Git repo, automatically the CAI and CD happens, and finally your application will be pushed into your end server, right? So if you want to achieve everything in an automated fashion way, we will try to achieve in this lower environments. Because what happened, right? If even if this automated fashion fails somewhere, we are not in a harm. Okay, we can fix it, but let's see whether how the continuous deployment happens in the lower environment. That's what the DevOps engineer in almost all organizations, what they do for the lower environment, he will try to he'll try to incorporate the continuous deployment strategy, right? The CD part he will try to implement this. It means that he will make it all this automated fashion. Whereas for the prod as well as for the disaster recovery, they will try to go with the continuous delivery. So continuous delivery is something where you need to take an approvals, where you need to, once the approval is done, then only you go with the deployment. So here the manual way of deployment happens actually. And as I discussed, right, some of the very huge projects like financial project, banking project and all, you cannot achieve the continuous deployment. It's not possible there. They won't do it actually, right? They need a manual effort. They need a in between. They need a human intervention. Is it fine, guys? So guys, I hope that you understood this, why we are, what is the difference between a continuous delivery and continuous deployment, right? So this is what you have to tell in an interview, right? So guys, I thought I will cover many things, but since it took a lot of time, right? I mean, whatever I am supposed to cover today, I think I have not even covered 50% also. So, but I'll not be continuing more now. I'll stop it here. So this is the first key feature of the DevOps which we are discussing. Tomorrow class, what we'll do that we will try to see other key features of the DevOps engineers. So there are so many tools are there. As I said, you need to understand the deployment strategy. You need to understand about the testing aspect, what we do, all those things, plus AWS account creation, everything and all we will be discussing in our next session. Am I clear, sir? So, guys, I hope that you understood something today, right? I will try to share all these notes into to the WhatsApp group, right? Go through it and try to go through it. So it was just a theoretical discussion today, no problem. In some classes, few classes, we might do some theoretical things. Plus, we will do some practicals. But when we try to get into seriously into all the DevOps tools, right? When you start learning about the Git, about the GitHub Actions, you will see that we will be doing a lot of lab exercise, labs things, so that we are aware about like how this tool works and how do you achieve everything by learning through lab only. So you need to learn in both the way, guys. You have to understand the concept very clearly in each and every tool, and plus you need to do the lab. Same thing with the AWS cloud. Same thing, everything, guys. Even if you're learning DevSecOps, anyhow, we will be covering all most of the DevSecOps tools. So in our upcoming session tomorrow, I will be covering even what are the different DevSecOps tools are there. Like DevSecOps tool, something like a SAST, SAST is there, DAST is there. So what are the different tools we are having? We are having something like Git leaks. We are having something like a SonarQube. We are having a Trivy tool. We have having OWSP Zap tool. We are having tools like Trivy tool. So many tools are there. Okay. So we will see what are those DevSecOps tools which are available, which is for primarily for the security aspect, and then how do you incorporate in our projects, right? Or how do you incorporate in that CI/CD pipeline? How do you incorporate it? All such things we need to discuss in our upcoming session. So it'll be quite interesting, and we have to know all these things, guys. I mean, at least we need to be clear with all these things so that whatever you learn in our course, right, it should be very much clear for all of us, whatever we learn in our upcoming session. So we will continue from here onwards, right? Key features of DevOps. These are first one. We will be second. We'll be discussing about IAC. We'll be learning about. We'll be understanding about what is a Terraform and all. We'll be learning about what is Ansible. We'll be learning about difference between Ansible and the IAC tool. We'll be learning about what is a containerization, what is orchestration. These are the key features of the DevOps actually, and also monitoring also, right? Fine, guys. I think with this, I'm going to stop the session. So, guys, let me know if you have any questions. Okay. Anybody? Akshay, Dipali?
Sir, tomorrow timing is same only, no?
Yeah, yeah. Guys, shall I stop the recording so that I want to tell you something? Yeah. Let me stop the recording.